Hi everyone, it's you, me, and Eli here today, so we'll see how long this lasts. Remember when we were talking about the circulatory system? We said that fluid can leave the circulatory system. It has to diffuse out of capillary beds into the tissues. And there's this other organ system, the urinary system, which helps to maintain the overall fluid volume in the blood and also in the extracellular environment. So we're going to focus in on that system in this chapter. The urinary system, in addition to just helping to regulate the volume of the blood, it also has this important job of allowing us to get rid of wastes. So the body produces more than just carbon dioxide. That was a waste product that we saw in the respiratory system. The respiratory system allows us to get rid of carbon dioxide, but there are other products of metabolism, other things that just start to accumulate in the blood, and we have to have a way to get rid of them. So the kidneys do a very good job of doing just that. And then we also have a lot of things in the blood that influence pH. There are a lot of ions, a lot of other substances, and if those started to accumulate to levels that were too high, that would influence the activity of enzymes and other homeostasis mechanisms throughout our systems. And so the urinary system has this major job of just regulating the conditions inside of the blood, maintaining pH, and we're going to see how it does that in this chapter. Just as a reminder, we've also, in the past, we have seen, when we were talking about blood, we mentioned erythropoietin. This is a hormone that's secreted, just a second, okay? Secreted by the kidneys, and it leads to the production of red blood cells. The major organs of the urinary system are the kidneys. The kidneys sit towards the back in the abdominal cavity. We have two of them. And the kidneys are the organs that produce the urine. The urine contains the waste products that the body needs to get rid of, other than carbon dioxide. And once that waste is produced, it travels down a ureter. Ureter is this tube. There's one on each side coming off of each kidney. And the ureters carry the urine to the bladder, the urinary bladder, which sits down here. The way that the urine is transported is by peristalsis. These are the muscular waves of contractions. They happen in other places in the body too, but peristalsis. So this is something that we don't have conscious control over. It happens automatically. And one problem that can come up is if there are kidney stones, we'll see this on the next slide, if there are kidney stones, then these peristaltic waves can be extremely painful. So we'll come back to that in just a second. The urine, once it is stored in the urinary bladder, it exits the body through the urethra. Both men and women have urethra. It's much shorter in women, and so this makes women more susceptible to urinary tract infections. It's not as long of a pathway for bacteria to have to travel up to in order to establish an infection. So women are definitely more susceptible to that. It can be extremely painful. Probably the best advice as far as avoiding UTIs is to drink lots of water. By doing that, that keeps fluid moving in the outwards direction and helps to flush bacteria out of the urethra. So kidney stones, let's talk about these a little bit. Kidney stones are crystallized objects, and they're usually built from minerals that are just ordinarily present. Sometimes when they sort of settle out and pack against each other, they tend to form crystals. Usually they're calcium crystals, but they can be other things too. And they can vary in size. Some of them are very small, some of them can grow to be quite large. Certain people are more susceptible to this than others. If they do form, then what can happen is if it's a very large stone, like here in this picture, this can actually block off the flow of urine out from the kidney down the ureter. So that's a serious condition. If they are smaller, then they can travel down the ureter, but it will be extremely painful. And so if this happens for a person, if a person develops kidney stones, most of the time most of the time it will be a small kidney stone, and so it will be able to pass on its own. The person will just kind of have to go through that painful experience. But there are some medications that can help with this process, and if the stone is very large, the person can undergo lithotripsy. This is basically it uses sound waves to shatter the large stone into smaller fragments so that the person would be able to pass the small stones. If that doesn't work, last case scenario would be surgery, actually opening up the kidneys and removing the stone. that's a pretty invasive thing to do, so that's kind of a last resort. The urinary bladder that holds the urine is lined with a muscle. That muscle is called the detrusor. The detrusor muscles, when they contract, they facilitate emptying of the bladder. And this is something that we actually do not have control over this muscle. This muscle is made of smooth muscle, so it's involuntary, and it's under control of the autonomic nervous system. So what is it that keeps urine from just coming out all of the time? Well, that's due to the fact that we have sphincters. So we've got this detrusor muscle that lines the whole urinary bladder, but then there are sphincters down at the opening, and when those sphincters are closed, it doesn't let urine come out. So there are actually two sphincters. One of them, the internal sphincter, is also smooth muscle. So that one is under control of the autonomic nervous system. But we also have an external sphincter, and that one is skeletal muscle. So that's the thing that we have voluntary control over, is that sphincter. So what happens, what is it that causes the detrusor to contract, is activity of a stretch receptor. When the bladder is full, the bladder becomes stretched, and stretch receptors send a nerve signal right up to the nervous system, and that causes a signal to be transmitted back down, and the detrusor muscle starts to contract in response to that. So it is the stretching of the bladder causes the detrusor to end up contracting. When the bladder is not full, there is what's called a guarding reflex. The guarding reflex is referring to the fact that ordinarily the detrusor muscles are being inhibited, right? If the bladder is not full, then the detrusor doesn't need to be contracting. So ordinarily, there's an inhibitory signal there. And at the same time, the sphincter is being stimulated to contract. So the sphincter is ordinarily closed. And so detrusor is relaxing, sphincter is contracting. Those two things together prevent urine from leaving. And then when the bladder is full, those stretch receptors cause the signals to change. Then the detrusor contracts and the internal sphincter opens. And then again, we can control whether urine actually exits the body through that external sphincter. So a problem that can come up, this is something that can come up at certain times in life, or it can be a persistent thing. Urinary incontinence, this is referring to if an individual has an inability to control urination. This can be caused by many different reasons. It could be overactivity of the autonomic nervous system, just stimulating the detrusor to contract when it shouldn't, and that gets hard to control, just based off of the sphincter, or it could be other issues. So in any case, there is a lot of help available for incontinence in many cases. That would be something to consult a doctor about.